Hello, welcome to Chapter 3. Today we're going to learn about cautions, about correlation and regression. We've talked a little bit about correlation and regression during the last chapter. This chapter we're going to go into things that we should look or think about when doing so. The main idea that you should get out of today's lesson is that association, however strong, does not imply causation. Uh, Only careful experimentation can show causation. And we'll talk about experimentation much more at the end of this chapter. Now, there is a strong negative linear association between year and infant mortality. And it looks like as years increases, so does infant mortality. But there might be some other factor like advancement in medical technology, uh, and that might be the thing that's causing it, and not just the year. And over here we have a nice little scatter plot of shoe size and reading index. And it looks like the bigger shoe you have, the better reader you are. But there might be some lurking variables in here. The saying that maybe age, as you grow, you read a little bit better. Uh, and that age is affecting both those variables. So these are two examples of association. Uh, that's association. Now, causation, a lot of studies want to show causation. We want to show that one thing causes another thing to increase or decrease. One example of causation, the increased drinking of alcohol causes a decrease in coordination. That's something you can study. You can run an experiment, have half the people drink alcohol, the other half not, see if coordination decreases, or you can have them check coordination before and after drinking alcohol. There's many ways to run an experiment about this, and we can see that one thing causes another. Association, there's no experiments involved. We can look at high freshman year GPA and see how it's associated with high SAT scores. Now, there's no experiment involved. We just look at it and see that, it's true. And it's something that you would guess to be true. But it doesn't necessarily mean that high freshman year GPA causes the SATs to go up. If you didn't work at all from your freshman year to your senior year, I would imagine that your SATs would be quite low. Now there's three main types of association. There's the causation, common response, and confounding. And we'll go into detail on what each of those is. First off is causation. A causation is a relationship that exists when a change in the x variable, the explanatory variable, affects a change in the y. So this is drinking alcohol and decreased coordination. This is something that we can run an experiment and prove it, and we can see this causes this to happen. Now, if there's another thing that happens in scatter plots in association, and it's common response. Common response, there's these things we call lurking variables. Lurking variables is something like the z here. It's causing both of the variables to change. And because of that, uh, we see it looks like there's some association here when really this is the thing that's causing it. This is true for our previous one with age and shoe size and reading ability. The scatter plot was just comparing the x and the y, when it's really the z, age, which is making both of those two change. Another example, TV and life expectancy. If we have the number of people, TVs per person, and the average life expectancy, you'd see the more TVs per person, the higher the life expectancy. But we couldn't lengthen the lives of people in Rwanda by shipping them more TVs. That just doesn't make sense. There's other lurking variables in there, like finances, that affect both of those variables. So, so obviously there's some other variables that are causing this. So, explaining association, confounding. Now here we have another variable that is just affecting the y, and this is not affecting the x. There are many examples of this. In this situation, It's known that a person's educational level and life expectancy are positively correlated. Yearly salary also has the identical effect on life expectancy. So you can have education level here, and that's going to affect the life expectancy. Now there's something else here, yearly salary. That can also affect uh, life expectancy. So there's multiple things that are affecting this, and it's hard to know what is causing it. So we call that a confounding variable. It's something where there's multiple things happening, and you have no idea what's actually causing this thing to go up. And it could be either, or it could be neither. We don't know. Now, an association between x and y, however strong, all by itself, uh, we can't say that it actually causes changes in y. That's a big idea. Hopefully, that point is made. Now, here's some on your own. Good luck.